All right, greetings everyone. This is the presentation for section 1.4 and 1.5 from our textbook. I'll let you know as we're going through this that when you're working through the homework related to this PowerPoint, you may need to refer back to the PowerPoint for section 1.3 as well, because some of the concepts that were covered in that come up on that homework. All right. So the first thing we're going to look at today are logarithms. And you recall logarithms are another way of expressing exponents. So often when we have a log, we'll have something like log base b of some number, which I'll call capital A here. And recall that what that's asking us really is what power does b have to be raised to give us a. So as I said, these are really just representing exponents, okay? And we think of that value b there as the base. And so again, we're trying to figure out what power the base has to be raised to get this number a that is inside of here. All right, so let's look at this first one, log base 2 of 8. And I also want to point out that the directions here say that we're going to do this without the use of a calculator. So we do not need our calculators for any of these problems that we see here. So we have log base 2 of 8. That's how that is said. And so as I just said a second ago, 2 is our base, and we're trying to figure out what power that has to be raised to give us 8. So really we're looking at this problem, 2 to what power will give us 8. And if we think, again, we're doing this without a calculator, think about it for a couple minutes. You hopefully see that the answer here is 3, because 2 to the third power gives us 8. All right, looking at the next one, we have ln of e, and that ln, recall, that stands for natural log, so this part right here. And natural log, if you remember, is basically another way of writing logs, but with the base of e. So here we would have, this is really the same as log base e of e. And so just like on the last one, we're trying to think for the base, which in this case would be e. What power does that have to be risen or raised to give us e here? And the answer, of course, is 1, because e to the first will give us e. So the answer for this one is 1. All right, I'm going to skip 3 and 4 for now and go on to number 5. So number 5 says log base 2, so again our base here is 2, of the square root of 8. Notice this problem looks very similar to the first one we did, that log base 2 of 8, except for now we have the square root. So we have to deal with that somehow. And in order to do that, we're going to recall another way to write roots. And you may remember that we can rewrite things, roots of things, using exponents. So another way to write this problem would be log base 2 of 8 now raised to the 1/2 power. Okay, so if you recall, anytime you have a root of something, you can rewrite that as writing it to a power of 1 over whatever the root is. So in this case, a square root is the same as taking the second root. So that's why we write that as the 1/2 power. And then you may recall also that logs have this special property that if you have log of something raised to a power, you can take that power and move it out to the front. So this problem would now become 1/2 times log base 2 of 8. which we found in the first problem that this part here, log base 2 of 8, that was equal to 3. So we know that this problem then is really 1/2 times 3, which if we multiply those two, we will get 3/2. So our answer here for this one is 3/2. Now for 3 and 4, I'm not going to go through those step by step. I will give you the answers for those though. So log base or log of 10,000, this one here is going to be 4. And then number 4, log base 5 of 1 over 125, that'll be -3. So I want you to think about why those are and figure out why those answers are those on your own. All right, let's look at using now some properties of logarithms. And this problem asks us to use the laws of logs to rewrite the following expression in a form with no logarithm of a product, a quotient, or with any power. So we need to basically take this. You see that we have things multiplied and divided and raised to powers inside the log. So we need to rewrite this so that it's actually more in an expanded form. So in order to do that, we're going to have to use a couple of, as it says, laws of logs, some properties that you may remember from pre-calculus. So one of those properties is about if we have the log of two things being multiplied. So let's say we have something like the log of A times C. Well, this is our sum log or product log. And if you remember what this is equal to is we can rewrite this as the sum of two logs. So it'll be log of A plus log of C. And then we also have one for if the two things in the log are being divided. So if we have log of A over C, and in that case we can write this as a difference. So log of A minus log of C in this case. So we're going to use these properties along with that exponent property we used on the last slide to again expand this log expression we have here. And you notice, hopefully you notice first, that inside the log we have things being divided, right? So we have this thing on top and this thing on bottom. So this would be like our A, this part on the bottom, this would be like our C. So we use this division property or quotient property to rewrite this. I'm going to do this starting over here. Oops. Okay, so using that division property, we can do log of the top. So x to the 16th times y to the 11th minus log of the bottom. So log of z to the 16th here. Okay, so it'd be log of x to the 16th times y to the 11th minus log of z to the 16th. Now, hopefully you notice in this first log, we have two things being multiplied. So now we can use that product rule. So take those and expand those so that it becomes log of x to the 16th plus log of y to the 11th minus log of z to the 16th. And so now we've taken this thing, we've expanded it out into 3 log expressions, and we're actually almost done here. Last thing we want to do now is use that property of log exponents, which allows us to take each of these exponents, move them out to the front of the log expressions. And so if we do that, this will become 16 times log of x plus 11 times log of y minus 16 times log of z. And so that there would be our final answer then. This thing that I've boxed in black. Great. Moving right along then. Let's look now at solving exponential equations. So if you recall again from pre-calculus, our motivation for learning logs was to be able to solve problems like this, exponential equations. And if you recall also what an exponential equation is, you hopefully remember that if you look at this word exponential, you see on the inside of it exponent. So exponential equations are ones that contain exponents. And actually more specifically than that, they're ones that contain variables in their exponents. And so, for example, looking at this first problem, the 4 to the 4x minus 3 equals 37, we see that here in the exponent of this thing on the left, we have our variable. So the x is inside of there. So that's how we know this is an exponential equation. And as I just mentioned, our motivation for learning logs was to be able to solve exponential equations. So that is the tool we use here to solve these. So the first thing I'm going to do on this one is take the log of both sides. So log here and the log here. And if you recall, what that allows us to do when we take the log is to take the exponent here on the left and move it out to the front. Okay, so this left-hand equation now will be 4x minus 3. That's being multiplied by a log of 4. Now we got to be very careful when we do this. It's that whole thing being multiplied by a log of 4. So I'm going to put parentheses here. Equals log of 37. And now that we have the variable out of the exponent, we just need to isolate it. So first thing I'll do, since the log of 4 is being multiplied by everything on the left-hand side, I'll divide that out. So divide by log of 4 here. Divide by log of 4 here. Okay, so these logs cancel out. I'm going to move this problem over to here now. So what we have at this point then is 4x minus 3 equals log of 37 divided by log of 4. And then we can add 3 to both sides. Okay, and be careful on the right-hand side there. We can't add the 3 to those two things because they're being divided and they both have logs. So we end up with 4x equals log of 37 divided by log of 4 plus 3. And then we divide by 4 to finish this off. So we'll end up with x equals, and be careful when you divide by 4, it's that whole thing on the right-hand side being divided by 4. So our answer is log of 37 over log of 4 plus 3, the whole thing being divided by 4. Now we do need to be careful here when we go to find a decimal answer. We have to be very careful about how we put this in the calculator. I would highly suggest using parentheses liberally, or one way to do it is put the whole top part into your calculator. So do this log of 37 divided by log of 4 plus 3. Get that answer and then divide the answer by 4. Or you can put the whole thing in at once if you want. Okay, either way, the answer that we get here is 1.401. So that'll be our final answer there. All right. I'm not going to go all the way through the other ones, but I do want to say something about number 2 here. So we have e to the 5x equals 16. Now we can start this one off the same way as the last one by taking the log of both sides. However, because there is this e here, we can actually use one of the special logs that we saw from the last one, which would be the natural log. So I'll actually, that's supposed to be an ln. Take the natural log on both sides, and if you recall, that works out nicely when we have the e. So you move the 5x out to the front here. So you would have, in this case, 5x times ln of e equals ln of 16. And if you recall, ln of e just becomes 1. And so that is why that is so useful there. Okay, if you have any other questions about these other two, feel free to let me know via email or a Walmart message, or visit me during one of my Zoom sessions. We move on to the very last slide here, which is some algebra with some expressions being multiplied here. Now, looking at this first one, 6 minus root 7 times 6 plus root 7. You'll see that we have all numbers in there, but hopefully this makes you think of something that we've used a lot throughout our mathematical careers, and that thing that you hopefully remember is FOIL. Right? So even though there are all numbers in there, this, when I look at it, makes me think of multiplying something like, say, 6 minus x times 6 plus x. And we know when we do that, we have to use our FOIL technique. So our first, outer, inner, last. So we'll go ahead and do that on this one. So we'll start by doing the f in the FOIL. So the firsts, so multiply the first things in each set of parentheses. So we'll do the 6 times the 6, which that is 36. Then we'll do the outers. So that means do the 6 times the positive root 7. And remember, because the 6 is not underneath the root like the root 7, we cannot multiply those two. So this will just become plus 6 root 7. Then we'll do the I, which is the inners. So do the negative root 7 times the 6. And just like before, we can't multiply the 6 and 7. We do have to pay attention to this negative sign here, though. So this will be a minus 6 root 7. And then we do the L, which are the last. So we do negative root 7 times positive root 7. Now we multiply those because they both have roots. We can do a little bit more than we did with the 6 and the root 7. So there's two ways to think about that. If we do square root of 7 times square root of 7, well, those are both underneath a root. So because of that, we can actually multiply them. So we can make this square root of 49, which square root of 49 then becomes 7. Or another way to think about this is if we have square root of 7 times square root of 7. Well, here we're multiplying something by itself. And we know that another way to write that when something's being multiplied by itself is that thing squared. So we're looking at square root of 7 squared, which we also know that basically a root, a square root, and a squared cancel each other out. So this just becomes 7. And hopefully that's not too surprising, because we noticed that back here, that's what was underneath the root in both cases. So here that's going to make us have a minus 7, because we have a negative times a positive there. We can combine some like terms. So notice, because these right here both have a root 7, they behave like terms. So those actually cancel out. And then we can combine the 36 and the negative 7, which would give us a final answer of 29. So that would be the first one. Okay, so let's look at doing a similar thing for the second one. Again, we're going to use that FOIL technique. So I'm going to do the first being multiplied. So we'll do this 3 times 3, or excuse me, 3 root y times 3 root y. Here, because we now have things on the inside and the outside of the roots, we can still deal with that. So we'll multiply the outside things, so that would be the 9. So that's 3 times the 3. And then doing the root y times the root y, as we just saw, that's going to give us just a y, because that relates to this one here. We'd have like square root of y squared. We'll do our outers, so 3 root y times positive 7 root x. And in this case, we again multiply the outers. So the things outside the root. So the 3 times 7 gives us 21. And then multiply the two things under the root, so that y and that x are both under a root. So we can multiply those together, which would just give us square root of xy. Now we do our inners, so this negative 7 root x times the 3 root y. Using the same process before, that's going to give us negative 21 square root of xy. And then we multiply our last, our negative 7 root x times positive 7 root x. In this case, we're going to get negative 49 for multiplying the things outside the roots, and then the root x times root x just gives us x. And then we have some like terms here we can again simplify. So the plus 21 root xy, the minus 21 root xy, those will cancel because they are like terms. And then we have the 9y and the negative 49x left. Those are not like terms because they don't have the same variables. So we end up with just 9y minus 49x here. And that will be our final answer on that one. All right, and that is all we have for this video. Thank you so much for watching, and I hope you all are doing well.